Okay, I'm working on this motor, this Westinghouse MobileAire, and I have a capacitor that I've put in place of that one. The resistor is bad, so I got two power resistors in parallel, but I got more problems. Actually, I drew that wrong, but okay, so that should be here. The one is low, goes through the resistor, connects to the capacitor into the yellow Y1. The other side of the capacitor goes to R, and Y2 goes to there. And I was about to do the resistances across the red in R1, the red in Y2, red Y1, red Y2. But from red to Y1, I'm getting nothing. So it could be a broken wire. So what I'm going to have to do, I got this right. We got pictures here. I'm going to have to disconnect this motor and try to figure out what's going on with the motor before I worry about this mess here. So that's where I'm at. All right, you would not believe what I had to go through to get this rotor, this cover off of this rotor, get this motor apart. The thing was full of dirt daubers, dirt dauber nests. The bolt literally welded itself to the side of the case here. Actually, it was this one. You can see it's all rough on the edge where I had to bang it out. I had to heat it up. This rotor is a mess. I have to clean it up. This thing has been sitting for a very long time. I mean, that's all that's left to the washer. Anyway, we got it out, but boy, what a job. And looks salvageable. Looks like I need to clean it, but boy, these bolt shafts though, wow. What a job getting those bolts out of there. I had to use heat, oil, bang, and try not to bang this thing too much, but I had to do what I had to do to get it out of there. And got it out. I made a few marks, but you won't see most of those because they're in between the metal. There is a little bit of pry marks there, but I had no choice. There was no way to fix the motor without getting it off, without getting it apart. It started banging this bolt right through the stator. I mean, that's pressed in with a machine, and you see how, I can pull it back, that ain't a problem, but it actually pulled the bolt, pushed the bolt out. This is the way it should be. And this stator, well, like most of these MobileAire units, have gotten really hot. See here? It's all black underneath the old dried out. See, this coil is really black. See how that one's copper colored? And that looks busted there like it burnt. I hope it didn't burn, because there's no way to rewind these. I mean, there is, but it isn't worth it. It costs $250 minimum to rewind a stator coil, and I don't do it. It has to be sent out, so then there's shipping and turnaround time and everything else. So we're going to hope that when I take this motor out, that the only problem is this red wire here is just broken off the head wire, because if the coil's busted, we're already out of luck. I mean, it practically wanted to pull the stator out with it, and the stator is bolted in with these two screws. I mean, that's how tight this was. You can see here, look at this. Look at that. That just welded itself to the inside of that housing. I'm going to have to run that on a wire brush and take it down just to get the housing back together again. You see all the oil I ran through there, trying to get it to break free. Well, I got it. Now I'm going to try to get this motor out of this housing. So, just wanted to document that. Okay, I got it out. Boy, you talk about a job, but I got it out of there. I'm just hoping these coils aren't shorted. This This is all dried out here, but I'll try to clean it off. And even on the stator, look at that. It's that dirt dauber stuff that I've been banging out of there. And okay, you can see what I mean by all this stuff is just falling off. See, got real hot. That's just right down to the string that was holding it together. Look at the string's totally deteriorated. See that string? Look, it just breaks. Totally deteriorated. So we got to hope that the coil is good. I'm not getting a reading from the red wire to the others. I'm hoping it's broken somewhere in here, like maybe right in this joint here, where it got kinked and hot. Get all this off, and what I'm going to do, if we get it going, see that? Right underneath that, look at that, the string just totally disintegrated. I can put, it don't need to be there, it's not a big deal, but the string, I mean, the black coil here is more of a concern to me. That got really hot there. That's the auxiliary coil, these two here, and this one here, and there should be, there's one there. You see it? Oh, I'm sorry, this is the auxiliary coil on the inside. This is the main coil that got hot. And that's what the red wire connects to, so look at that. And you see how when it got hot, it burnt this down to the copper? That's what makes me worry about it shorted somewhere, because if the copper touches each other and it doesn't have even a thin coat of shellac on it. Now some of that is probably fine, it's probably still shellacked, and it just turned black. And in places where this was still sort of over it, it's shining, it's showing shining copper underneath. We don't know. There's a wire there. Let's move that out of the way. That string ain't holding it anymore. See this string? It's gone. So that's not a big deal, because I can re-shellac it. I can spray it once I clean it, and that'll kind of keep it in place. But I can't do anything if the wire's shorted or broken inside somewhere. If it's broken inside or if it's shorted, it needs to be rewound, and I can't do that. It's beyond what I can do. This side, again, you see it got really hot. This is one of the coil wires that connects from one coil to the next. And it's still connected. Actually, it's a head wire. Comes through from here, goes through over to there. And the other one's down further down here. These are the head wires here that come through from the other side. So I got to run a new one through. Because see, the insulation came off that, so that's probably shorted right to the core if it's touching the core anyway. Yeah, this one's gotten extremely hot, a whole lot hotter than most. I'm just barely rubbing it with the tips of my fingers. I'm not using anything that's going to hurt the coil. I just want to get it off so that when I shellac it, I can get shellac in there. Okay, that wire's just connecting two coils together. And it goes right there, that's not a problem. Okay, there's the other head wire there. Oh boy. Okay, that's connecting the two together. Here's one, and you see the insulation is all rotted off the wire here. If those are not shorted together, it'll be a miracle. See them? This is your three head wires. That's these three wires, this one, and this one. And they are definitely shorted here. I mean, rotted away. The insulation is gone. You see that? So the question is, Did it burn out the coil? Okay, had to use that under here to get the stator out. It's unreal. Okay, and then of course you see in there, you see what we got in there. Just a royal mess. That's after I banged out all the dirt daubers. So that's got to be cleaned. I'll just set it here. Get this out of the way, clean up my mess, and then we'll check the coil. I'll be right back to do that. Okay, first thing we're going to do is check this red wire. I got the clip on there, and let's see which one it is. Which of these three used to have red insulation on it. Okay, that's measuring 0.2 ohms, so that's either shorted or that's it. Let's try this one. Okay, that's open. That's bad, by the way. None of them should be open. We should have a resistance. That's the problem we've been having. So I have a feeling we're in trouble. That one's open. That means that this is the red one and it's not connected. This wire here is not connected to the other two. And that is the red one. The red one is good and it's not connected to the other two wires. It's not shorted. So if I come across here, I should have a reading, but oh, no, I don't. No, it's open. Huh? Meg ohms isn't going to be any good. It has to be ohms. See the little M in the corner? Anything with meg is not going to do it. You can see the M better. It's got to be ohms. Shoot, this coil's dead. See, I'm not using these at all now. I'm just going across the coil itself. From here to here, we have a reading, I believe. No, that means the reading, oh wait a minute, I may be on the wrong one. Maybe these two, yeah. Okay, that's 20 ohms. See, it's just an ohm symbol. There's no M. And that's fine. That is the, I believe that's across the center of, okay, you see, here's the broken wire. Here it is right here, where it burnt off. See that? I'm putting right on here. See where it's wrapped around here? And it's got like a bubble on the end. See the bubble? That's where it fried off. So we're going to open that up and bring it out of there so we know that's the bad one. That's the one that's supposed to go to the red wire, which is this coil wire here. See how it's melted? It's like a ball of copper there. That's from the heat when it got real hot. And that is the other side of where this wire goes, this one here. Somewhere it comes out and it connected here and it bubbled off if we can find it, and it's not a bad short. Might be able to put it back together. But right now it's looking like this stator short. I knew when I checked the resistances on that red wire that something was wrong, and you don't almost never get a no reading. If you get no reading, that means there's a wire broken, because even a short will show you something. It will show you a short. These go together, and I don't see any broken wire on that. This one goes together, and there's no broken wire on that. This is the, get that off there. This is the auxiliary winding here, and there's no broken burnt wire here. So these just get wrapped around and they just stay on the side of the stator. That's where the coils are joined together. That's joining this coil with this coil. This one's joining this auxiliary coil here with this auxiliary coil here. Those are fine. The one that's a problem And I'm going to disconnect this to get it out of my way. Shut that off. Get some more light on here so we might be able to see better. Okay. I didn't get that off there. The one that's a problem is where this one went to. Now we know the length of it, right? We know that this laid down somewhere like that, probably. So it either went here or this laid down this way, in which case it burnt out over here. But that doesn't mean anything. Question is, why did it burn off? That sounds like a short. And even if I find it, this is the wire, there's no guarantee there. This wire is going around somewhere in this coil. It's going through this coil, and somewhere in this general area it burnt free. And this is the other half of that wire. And that would be sort of like the center of these two, the two yellows. So that, well, not necessarily center, but a tap off these two yellows. So this one, oh, sorry, these two yellows, this one and this one measure 20 ohms. That's awfully low current, low resistance, I mean. So that's 20 ohms. That's possible. And then this one would be high to here and high to here. These two would be high and these two would be high. One of these would be higher than the other. But we're not finding anything that goes to there. That doesn't go to there, and that doesn't go to there. And it did off this yellow wire. But what I'm concerned with, okay, so that means that this wire to this wire is 20 ohms. These two coil wires here are 20 ohms, and they're probably right, and they would probably be this outside coil. And then this red coil would most likely go through the internal coil and then jump out to the outside coil at some point. And this is the red one. So the red one here, yeah, see, it's the internal coil. That's this ticket. And so that one went around the internal coil, and then at some point it jumps to the outside coil and connects to here, or connected to here. And that would give you high and high, well, high and high. These two, these outer two and these inner two, would be high and high. One would be higher than the other. And then the auxiliary, which is the two that will work in these two, they just go around this outside coil, and they would be low resistance because that's a bigger wire. See, this wire is a heavier gauge. Yeah, this wire is a heavier gauge, not much heavier, but it is a heavier gauge, which means it's the outside coil because that's a heavier gauge wire. This is the inside coil. It's a thin wire. These are inside coils. These are outside coils. So this is where they joined, when they were wrapping them and they ran out of wire, this is where they joined them together to continue wrapping. I'm afraid I'm not going to be able to fix this. I'm afraid I'm not going to be able to fix it. This is a thin wire, so this would be going, this is a thick wire, yeah. This is a thick wire, goes to the outside coil. This is a thin wire that connects the thin inside coil. This is the jumper that goes from the inside coil to the outside coil. Oh, you hear that? Now we know this coil is definitely shorted because I'm getting continuity in places. So I get, yeah, see there? I don't think it's me touching it, no. Okay, I'm getting continuity. Where am I? Oh, it's, hold on. Yep, where the insulation burnt off. See that? When I move that way. So it's when where the insulation burnt off is touching this here, right there. So that's shorted there. The shellac is off right here. That's not the only problem, because now I'm not touching it. Just moving it around, it's shorting to the others. I would replace this one, so I'm not too worried about that. But if it's shorted in the coil, it's a big concern. And I can't find. Can't find where that would have went to. These are the mains, and they're fine all the way around the main is working. Well, all the way until it jumps to the center. So this is the main here. This is the end of one of the main coils, and it jumps to the internal auxiliary coil. And this is the auxiliary coil, this is the main coil. Ooh, that's hot there. I think I burnt, it's all burnt there. See that? And that's the lacquer's fried on it. Hear it? Yep, coil shot. See what this sounds like? You don't hear nothing. That's the way it should be. That's the shellac on the wire. Yeah, here too. This is short. It's shorted. See? If I touch that, just one of them will give me a continuity, probably this one. See? I should not get no connection there. This is from coil loop to loop. That loop is fried. And another place here in this black coil. I'm touching it somewhere, but I can't see it. Right there. See? I can see it now. The clip is actually knocking some of the insulation off. See? It's all fried. See how black it is? This is no good. This fan's dead. I'm going to have to let the owner know. So I'm going to upload this video, and the owner can see it and see what's going on. But this stator is dead. It would need to be rewound. Like I said, rewinding one costs $250 and it takes months because the guy's so backed up. There's nobody that does these but one guy that I know of, and he's on the Antique Fan website, club, Antique Fan Collectors Club, and his rate is $250, and he's backed up. I already got one in queue for him. That's from well over 100-year-old fan. This is a 50s fan. This isn't, and this is not a high-end fan. Anyway, I'll have to let the customer know his stator is toasted, and there's nothing we can do. He'd have to get another stator from another unit and put it in here. Thanks for watching.